Hey, hello, and good noon, everyone. So, back after like almost we had 12 days of gap in between, and also, I guess today, few candidates, a few of the students are away, busy with small workshops, etc. So, we'll be continuing with the same topic of that is the RAG topic, and like we'll continue with the RAG, what we were discussing earlier, and we will have the next important step forward, and we'll keep this
Anand,
session. Yeah,
sorry. Just that the last collab that at least I don't know whether I missed it. The last collab I received was that Hugging Face number 13. After that, there was one exercise, right? We did
yeah,
full training. Yeah,
I
that
guess
maybe I missed it.
I have missed sharing it. Right. Let me do it after the session.
Yeah,
Right.
yeah, sure, sure.
Sure.
I missed it.
Okay. Right. Right. I'll just we'll just revise in 15-20 minutes what we had done previous.
Yeah,
Right.
sure.
So we'll just do that. Right. Now, basically, what we will be trying to do is that I do not know what is happening. Just give me a second. My system has started acting weird since few days. This is better. Okay. Yeah. Okay. The web version was actually creating a lag here, so I switched to a desktop version. Basically, I'm also getting used to it. Okay. All right. So basically, what we discussed in the previous sessions was we were discussing about RAG, right? We had discussion about RAG, that is, what there in the RAG, basically, what in the RAG. So RAG was what we had is, you know, we learned how to fine tune our models. We had learned how we can fine tune our models, right? And after fine tuning, basically, the next thing was that uh, our models are there. We had our models, and then we started. This was, let's say, this is my model, and then, but either we end up with fine tuning, right? In fine tuning, also there were various methods of fine tuning available. What are the various methods of fine tuning that we had discussed? The various methods of fine tuning that we had discussed were like, first and foremost thing was the full fine tuning, right? We discussed full fine tuning, and then what we discussed is basically LoRa fine tuning, LoRa fine tuning. Then we had is QLoRa fine tuning, right? QLoRa fine tuning, right? These were the applications basically, or the fine tuning methods. But however, in full fine tuning, we had an advantage that all the layers are trained. So basically, all layers are trained, and all layers are trained. But this was not the case with LoRa and QLoRa, in which what was happening, uh, it was creating one more matrix. It was creating one more additional low. rank matrix. It in both of these methods, what is happening? It creates a low rank matrix. It creates a low rank matrix, right? And in this low rank matrix, what is happening? In this low rank matrix, it tries to basically train compared, I mean, it tries to train the new data set, whatever we are having. So basically how it happens, just for the refresher, if this is my original model, this is my original model, and then from after getting from original model, this will be low rank matrix. This will be a low rank matrix. This is a low rank matrix, right? And then what happens in this low rank matrix? This low rank matrix basically gets trained, right? And then finally we get the output. And it is basically this matrix that is getting trained again and again. And this core model is not being touched because this is a very heavy model and it is hard to, so what happens? We are not able to add new knowledge. It cannot add new knowledge. It cannot add any new information. But what it can do is it can actually uh, add new behavior. It can add new behavior. It can add new behavior, right? This is something it can do, right? So this was what was happening till now, right? And then how can we, okay, with QLoRA, you can basically add new behavior. But what happens about adding new information? About adding new information, then we discovered that, okay, we will go with the RAG architecture. Okay, Retrieval Augmented Generation. I will just go through the RAG once again because obviously there can be a chance that we might have forgot all of these things. I'll just go with the RAG. So what happens with the RAG? Right. So what happens with the RAG architecture? So what happens with RAG? Right. So in RAG, basically, what is happening here is in RAG, retrieval augmented generation, right? Goes as retrieval augmented generation. Okay. And what happens in this? So basically, we might have huge amount of corpus of data. And today I come with that term. Usually I spend a lot of time in arranging for that data. Today I have some huge amount of data and I have around 19,000 contexts today, right? So which becomes a fine benchmarking for us, right? What I have is 19,000. So I have some huge amount of data. I mean, although uh, this is not still very huge, but yeah, in real time, it can mimic a kind of real time scenario. 19,000 context is still huge. Uh, in bigger scenarios, there might be even bigger ones, and then we will learn, few ways how we can step by step improve the behavior of our RAG. Now, here is my external data. Here is my external data. This external data can be anything. Let's say external data can be it can be related to anything biology, or it can be related to anything, you know, physics, or anything like uh, quantum physics or anything, so it can be anything that your model does not knows, right? And this here is your model. So basically what happens now, this is huge data, and this will be getting, we will storing this data into vector database. We will store this data into vector DB. We'll store it into vector DB, right? We will store it into vector DB. Now, what we'll be doing is we'll be obviously storing this into vector DB, right? And once we have stored it into vector database, now comes the whole pipeline. And whole pipeline, we had just started using LangChain for it, right? We started using the LangChain framework. Now, what we started doing is basically we had our vector DB here. Then basically we will have our query, right? This query can be anything that what was last war, anything last war at France, anything or anything about French Revolution, right? It can be anything that your model is not knowing. Now, what it does is, right? Uh, it can be any history or any information it can be. Now, the model, what it does is basically here it comes, and first is the retriever piece, right? So here we have a retriever piece. This is my retriever piece. Retriever. So what retriever does is, right, first and foremost thing, this query will be actually, it will be converted into embedding, that is text embedding. It has to be converted into text embedding, right? It has to be converted into text embedding. And now we have already vector DB. What has happened in vector DB also? It has also converted into text embedding. So basically this has also converted into text embedding, right? This is also text embedding. And now what is happening that, okay, we have vector DB retriever and it got converted into text embedding. Now this text embedding will go and it will perform the search, right? It will go and perform the search on this vector database. It will go and search this search vector DB, right? And then it will come up with some candidates, probable candidates of answer. And this search is happening based on cosine similarity. It is happening on based of cosine similarity, right? And now it will come and come up with few candidates of answer that, okay, this is my option, context 1, context 2, context 3, based on the k that we have. If let's say k is equal to 4 or 5 or anything, it can be, right? Based on that, let's say if k is equal to 4, it will come with 4 contexts, c1, c2, c3 and c4. And then based on this context, basically it will be fed into my large language model, that is LLM. It will be fed into my LLM and I will get my final answer.
Anand, one doubt here.
Yeah. Yeah.
So do we need LLM over here? Because I guess only till here we need only embedding model, right? So is it LLM? What is the purpose here? Like,
Yeah. Let's say this context can be one page, complete one page, right?
yeah,
Let's say
okay,
you have fed complete history books into it, right?
okay.
And then this context will be complete one page. Now LLM is responsible. Now let's say you say that what was the last war at, when was, basically it should be when was the last war at, when was the last war at France, right? So basically this LLM will come and it will give you the pinpointed answer. Now this will fetch you the whole page in which probably the answer is present, right?
Okay,
But the
okay.
exact answer will be fetched via LLM. Exact answer that, okay, the last war that happened at France was in some like
So,
maybe in
so
World War II.
hallucination is still possible, right? Since we are using
Hallucination
LLM.
is still possible if you are using LLM. Hallucination is possible if you want. I mean, if you do not have to intelligently extract the answer from this, then basically what you can do is you can actually use, instead of LLMs, you can use encoder models.
Yeah,
And,
okay.
encoder models will be very strictly responsible for fetching the data from context only, hence
Yeah,
no hallucination,
right.
right? But
Understood. Yeah.
yeah, this weekend, what I presented over the, this conference was also the same thing.
Okay.
They were actually going again and again over the hallucination problem, and then the agents. So basically with agents, if agents start hallucinating, the whole pipeline is destroyed.
Yeah, I know.
Then
Because Anand
basically
just wanted to
yeah,
add, like I had tried because I tried one out-of-the-shelf application called Rackflow. It is an open source
Correct,
application,
correct, correct,
Rackflow.
correct.
So
Right, right.
there we added one embedding model, and we had to add a chat model.
Correct.
So once I added, then but whatever files we gave, it takes only TXT files, text files.
Right,
So
right,
we
right.
gave, but it was answering, but it was hallucinating almost 50-60% of the time.
Yeah, yeah.
So we
It
couldn't
happens.
restrict it
Yes.
to the
Yeah.
content.
In that case, was it for your official purpose or for your
Yeah,
hobby
yeah, it
purpose?
was if no official purpose. We were trying to create a knowledge management database kind of thing, like putting
Then
all
in
our
that case,
yeah,
all this knowledge that I'm giving you, you can easily build it. Uh, and I'll also show you how to test it, basically how to test these models, right?
yeah,
So you will be able to achieve an accuracy of around 90 to 92%. And you can reduce the hallucination also. There are various ways using which we can reduce hallucination. Now, these tools don't come with such rich options. Now, the one
yeah,
example is even if you are coming with LLM, let's say, uh, you remember the first previous day, let's say, previous classroom, I was trying to basically concentrate on Quen model,
yeah, right,
right? Right.
yeah,
The reason was that I can easily provide my feedback to Quen. I am using,
mhm,
as of now, I will use Gemini, right? I can't
okay,
provide my feedback to Gemini,
okay. We
right?
used actually using Valama. We used Llama
Right.
3 billion, I guess.
Right, right. Now, what we will do, the whole idea is I want to demonstrate how to improve the accuracy of these RAG systems, right?
Yeah, no, yeah,
So,
good, yeah,
yeah. So we'll go ahead and we'll start. We'll see that, okay, this is the accuracy, this is a bad accuracy. And very good example can be you can actually, uh, in your local system, you can start building that whole thing also,
sure, sure, sure. I'll do.
right? Correct. Sure.
Yes,
Right. Now, out of the box solutions are having a lot of problems as of now. I mean, what is happening if anyone is having even small amount of knowledge, they want to build a product and they want to deploy it. But it is not the case. The accuracy is a big problem, and accuracy does not comes out of the box in AI solutions. Right. Okay. So this is a complete RAG system that works. Right. Now, basically, obviously, what we had done previously, we tried to built a RAG solution in our previous thing. We tried to build a RAG toy RAG. Basically, we tried to build a small toy RAG solution, right? It was a small RAG toy RAG solution, isn't it? So in this toy RAG, basically what we tried to do was we tried to even we took some small text file here, right? We took some small text file and we tried to run across. I'll just show that text, that collab notebook, and I'll also share in the meanwhile, right, so that all of you can recall basically what was there. Let me just go to that and okay. All right. So this was the notebook, wherein we built our small toy example, and then using LangChain, you don't have to use even OLAMA, right? You can directly load these GGUF models directly into your this thing, and LangChain becomes easier sometimes. I mean, you can use any library, although there are various other libraries like you can use Llama Index, LangChain, or even Haystack. You can use any of.
And then later you'll share this collab, right?
Yeah, yeah, I'll share it
Yeah,
right
good.
now. Right.
Yeah, okay.
Correct, 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 correct. Right. So basically, what we tried to do was this was a very small example, right? We tried to load from a like book. like Game of Thrones book, and I was basically just using, I guess the model that I was using was, we were using ChromaDB, and then we were using Quen here, model path, and yes, we were using Quen 3 billion model. So GGUF model, this is what we were using. But anyways, the question comes here very strong that, these are some toy examples. What about some real-time examples? And we want to see, I mean, when we jump into real-time scenarios, then obviously these things start failing. So obviously for that reason, what we are going to do is we will be actually starting with a new example today, basically. Now, one more important point that I will be that today is that, first and foremost thing, go ahead and for the practice purpose, this is just for the practice, go ahead and obtain a free key, uh, so basically Gemini API key, go ahead and obtain a free key. So you can just go ahead and obtain a free key. So Gemini is offering a limited uh, data usage, and this limited is fair enough for all our models. I mean for all our practice purpose. So you can use Pro Flash most of the time. Flash is quite fast, so I have started using Flash Lite because I don't want and I want my credits to last long. So I'm using Flash Lite. So you can go ahead to use Flash. Pro is actually for advanced reasoning, and it is also costly, and it becomes, for any reasoning tasks. Flash is usually good for most of the tasks. I'm using even lesser than that, Flash Lite. I can continue to show on Quen. I don't have any problem. But improvement of RAG, we will be going with Quen itself. How to improve, because obviously fine tuning this Gemini on the cloud will not be possible. What we'll do is, okay, so we'll go with 19th exercise. Now the number is not literally 19. There are actually two exercises in between after 13. So numbering is kind of not in the proper order. Okay, so RAG advanced. All right. So in RAG Advanced, basically what we will be doing first and foremost thing, we will be using, now you can go ahead and obtain your key. I have my keys here. So I will be using that keys only, right? You can go ahead and obtain your keys, and you can use those keys for playing around, for all of the experimenting. Just you be cautious with the key so that you don't exhaust it very easily. I mean, right? Otherwise, obviously, you can go ahead and use anytime uh, the basic models from which we have been loading. You can go ahead and load them. Right now, I have my keys, like I said, and just go ahead.
And if it gets exhausted, we can create it from different IDs, right?
Yeah, you can do it, but do not use it in the production. And
No, no,
production,
for practice purpose.
yeah, yeah, for practice you can do it. Yeah, obviously, right. So this time we will use the Gemini API for practice. Earlier, I did not knew it that this was coming free. Once I went to this event, I got to know. Right. Okay. So first and foremost thing, let me first, run these a simple basic example, and okay, we will run it. So I'll have to do first some installation. Pip install LangChain. I guess the library name is LangChain underscore Google underscore GenAI. Next, once we finish off this all of this thing in RAG, I will request everyone, at least, because then we will have to cover the agents, which is a very hot topic nowadays. So GenAI, okay, right. This is just an easy adapter for LangChain that is available from uh, Google. So we can just use it, and then we can go obviously, right. I'll go in. I'll just upload my keys here in the text format. I've just kept it in the text format so that I don't have to display it in the video, right? Port OS and import from LangChain underscore Google underscore GenAI for LangChain Google AI, right? That is correct. My spellings are wrong. All right. And then I'll just read my API underscore key underscore file. API file name is gem key dot txt. Right. I'll just read it. Okay, and API key is loaded. I'll just add the strip statement. Done. Okay. Why is it not from LangChain underscore? From LangChain pip install. This is okay. Pip install. Mhm. LangChain Google underscore GenAI. That is correct. Time start session. Mm, 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 mm. LangChain underscore Google underscore GenAI. Um, LangChain. I guess let's install first. Let's install LangChain and LangChain community. I have no idea with this new change. How do I accept this? Okay. All right. And then, all right, it is there. Gem key text and it is loaded. Okay, done. All right. And then let me just, put it in the environment so that I can use it everywhere. OS dot, I guess it's OS dot environ and Google underscore API underscore key is equal to API underscore key. Right. And that's it. And my, okay, done, loaded. Now, like I said, I will be using the light version, Gemini 2.5 Flash Lite. So it will go LLM is equal to same chat, Google generative AI. I'll have to provide the model name and I'll have to provide the temperature also. I can provide with the temperature or else it will work with the default temperature. Now temperature is basically the probability which we were doing few weeks ago. We were doing it from the program itself. Now it has become temperature, right? So my model name is Gemini 2.5 Flash Lite. I hope so. This is the right model name, Gemini 2.5 Flash Lite. Right. And then let's check. Okay. And I'll go with LLM dot invoke, like response is equal to LLM dot invoke. What is capital of, let's say, India, and what's it famous for? Okay. Can print it using response.content, response.content. And this is very simple usage of capital of India is New Delhi. New Delhi is famous for multitudes of things reflecting its iconic history, culture, significance, and XYZ, ABC, and so on.
Anand,
Yeah.
so here we are not using anything. Are we using this from Hugging Face, like this model?
Yeah, this model is we are using via LangChain
Okay.
from Gemini.
Okay, Gemini. So okay.
Yeah.
So we are not using Hugging Face anywhere.
Hugging Face, now this is a wrapper over Hugging Face. LangChain is built on Hugging Face only,
Okay. 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 Okay.
right? We can do all of this using Hugging Face,
So here
right?
I won't need my Hugging Face token, right? For this to use this
Yeah.
collab for it.
If you are using model from Hugging Face, then you will have to use that,
Okay.
right? Right.
Okay.
If you are using the model, because Hugging Face also hosts some model. If you are using the model from Hugging Face, then you will have to use that, else not,
Okay. Okay.
right?
Yeah.
For using Hugging Face API, you don't need Hugging Face tokens.
Okay.
Right. Now, coming back to the next point, that what we need is, okay, this is something we have just set up our first Gemini model. Now, next is basically I want to set up my RAG pipeline, like simplest RAG pipeline. So what we had discussed here, I'll just go back to the whiteboard. Right. What I was discussing here, basically this thing. So we were discussing about this RAG, Retrieval Augmented Generation, wherein we want a big, huge data set, and we want to load this huge data set into my vector DB. So, okay. So first and foremost thing, what I have done, I have actually downloaded a huge data set that is called as quad.json. This was available here. So I have done is I have downloaded all of this data set, and then sorry, right. So I have this huge data set called uh, as squad data set, and this squad I am first reading from the JSON file, right? So I have this squad data set, squad, right? And I have this JSON file, JSNL basically, wherein data is present here. Now what I will need to do is I will need to first read this file. I'll need to read this file, right? And then I'll have to check this, that is store the data, and I'll have to use embeddings, right? I'll have to use embeddings. Now I am using sentence transformer open source embeddings, sentence transformers open source embeddings. Instead of using this, if you want even higher accuracy, you can go ahead and use either Gemini embeddings. You can go ahead and use Gemini embeddings, right? You'll have to pay something. I mean, they're not very costly, and you can go ahead and use OpenAI embeddings. There are a lot many embeddings that are present, right? But again, even with this embeddings, if your text is not extremely complex, it is properly formatted, you will be able to get, at least try to run it. You'll have to try it. What is the accuracy you are getting with sentence transformer? What is the accuracy you are getting with Gemini embeddings? Either Gemini or OpenAI, both are equally good. I mean, it's not that you can use Gemini embeddings along with it. So as of now, we will use this sentence transformer embeddings, and we will store this data into the vector DB. So first and foremost thing, plain storing the data into the vector DB, right? We are not doing anything fancy. What we'll do is so like I said, preparing the data set is the first big task here, right? So what we have to do is, I'll just first load the data set, right? So here we come, and I will load the data set. Okay, I have this is loading. In the meanwhile, okay, next is basically we will have to write a parser for it. So let it load.
This parser is file type specific. Is that file type specific? Like for
As
TXT,
of
there will be a
now,
separate
yeah,
parser.
as of now, right, that is file type specific, but as of now, we will have to write a custom parser for it because this data is not very much compatible with the LangChain. So I'll have to, because I'll just show it is present in context, answers, answer position, and all of those things, so that it can be used by encoder, decoder, both kind of models. It can be used by generative, non-generative models. So basically, they have arranged the data set in this format. So I will be basically just reading the JSON file itself, nothing fancy here, right? It's there. And if I just open this file, oh, it has started to, mm, anyways, I'll just showcase this file. Mm, If you see this is the file that it looks like. Now this file is basically what is happening here, you know. It is having squad, and this is the context, and after the context it will contain few questions and answers, right? It is having these questions here. If I go, I'll just go slow so that this is a huge context. This is a big context. Now if you see, even here there's a question here, QoS, and there's the answer for it, and there's a question. In which year did Albert Zam begin comparing aeronautical models to Notre Dame, right? And they have a unique ID, they have a question ID, they have question tokens. Now, when you are preparing RAG, you will have to prepare this kind of data set from your data. Now, it doesn't has to be manual effort. You can actually do this even automation, right? We'll just discuss about it later on. Using LLMs, you can actually automate some of this data. Either you can have LLM on your local, or you can have a cloud LLM, but you need this kind of data set, because if you're not having this data set, if you're not having something ground truth, what we call, then you will not be able to compare it with anything, right? You will not be able to get the numbers. Like as of now, my accuracy is 80%. Then I did this, I reached to 85%. Then I did this, I reached to 90%. If you do not have this ground truth data set, you will not be able to do that, right? Now, let's go ahead and try to parse this data. Okay, so I'll start parsing this data here, and now I have squad, I have, okay, file path, go with squad underscore data is this, and then with open file underscore path as file for line squad underscore data. Now, there is just small change here, uh, change in the sense from the generated part import JSON. I'll just import JSON, and then it says file encoding R. I'll just mention the encoding equal to UTF-8. Okay, for line in F squad JSON dot, okay, dot load. Now this should be actually JSON dot load is my new record, in the sense the new line. In this new line there are a lot of things. It has context, it has questions, it has answers, right? And then I'll go for is context is equal to record dot get context. Okay, and then it has the data in questions format. I'll go with questions underscore list. This is my questions underscore list. So QAS, I had already parsed this data, so I already know what it looks like, because there are a lot of things when you have to showcase this huge data set. I had to, for checking it in the vector DB, it took me around what, I guess 40 minutes for doing that. So I have already prepared all of that data, so that we don't waste a lot of time here. Record.get, and I'll share that file also with all of you, but you can also go ahead and check in that data. Record.get QAS, and it also has some mention of if it is not found, then what needs to be done. So it will return empty. Now from QA in QS, question and answers, QA dot question and answer. Why is there unexpected indentation? Hmm. What is the problem? Record for line in record. This is fine. Okay. From question QA QS. Question and answers. Question is there. Answer. If answer is equal to, and then if answers, then answer is equal to answers of 0, else answer is equal to blank. And then I will add all of this to my question list. Questions underscore list dot append. I need to append question to question. It has to be in this format because there are two values, so I'll have to enter in the dictionary format, and then I'll have answer, and it goes as answer. Right. Question underscore list dot append, and then we have answers. Question underscore list is done, and we'll add it to our squad data also. It should go into the previous loop, I guess. Context and questions underscore list. If it is not empty, then squad dot data append context and questions, right? QS question list. Right. I have this question, and let's see. Invalid syntax from Q in QAS. It has QAS. Print QAS. Why is it not printing? Why is this a problem? Record.get QAS and blank, right? Sorry, it should be for. My bad. Okay, I got it. Now let me have a look at my data. Squad underscore data of 0. Let's say I have this. I'll just copy paste it. Squad underscore data of 0, and it says, see, I have this question, and then I have this answers at least. Now it doesn't has to be that all of your data because many a times you don't even know this is how your data is, but at least for testing, for testing, uh, let's say if you have 10,000 records, right, roughly 10,000 records or 20,000 records, then at least have 1,500 to 2,000 such data sets, and you don't have to do it manually. You can have a look at some of the data points manually, but some points you can, or obviously all of the points you can automate it. Now I have my data here, and then I can do a lot of things with it. First and foremost thing, I will have to check in my data. I'll have to check my data into my vector DB. So I can use FAISS or Chroma DB, anything that I want. let me first actually, I'll have to get all of these accelerate and FAISS TB. I'll have to install all of this. So let me install pip install transformers. LangChain community, I guess will be fine. FAISS TB I'll have to install, right? Transformers accelerate LangChain already done. LangChain community is already done. Okay, community is already installed. I'll just go with FAISS CPU. It will take some amount of time to install. In the meanwhile, I'll try to install import statement from LangChain underscore community dot embeddings import Hugging Face embeddings from Hugging Face Retrieval QA LLMs vector storage wait from LangChain underscore Google GenAI import chat. Okay, then from LangChain dot vector stores import F5TB. I'm using another 5TB, right? Then text we do not need, right? At least for this document store, we will need from LangChain dot document store retrieval QA we will need, but will okay. LangChain dot doc store document import document. Right. We have this. Let me install it. Okay, done. First and foremost thing now, like I said, you can use any of the text embeddings. You can go ahead and use Gemini embeddings. or OpenAI embeddings, whatever you wish to use. I will showcase once how to use Gemini. I mean, there is nothing. You just have to specify the model name. That's it, right? So only this needs to change, nothing else. As of now, we are using sentence transformer. So I need to just, this is a local model because 18,000 documents, if I just burst it through this 18,000 documents from Google embeddings, I do not know. I mean, my complete usage may exhaust. LangChain underscore community. Earlier, I was planning to purchase this OpenAI API for showcasing all of these things, but then I learned that okay, we have pretty much free things with this, so we can utilize this. Community.embeddings, Hugging Face embeddings we have already imported, right? Then embeddings is equal to Hugging Face. So what is this doing? This is going to convert your text into embeddings, that is into vectors, right? Sentence, sentence, sentence transformers. It should show transformers slash all slash mini. It is not showing any version also. I guess it was mini LM L6 v2. I hope it. All right. It will just take few minutes to load this model. Okay. All right, done. Next is I have this thing. Now let's check that what was the total length of our squad data set. You know, we have to check in the data. Squad length of, let's say length of squad underscore data. Oops. Squad JSON squad dot data dot append. Hmm. Hmm. There's some problem that has occurred. No. What is the problem? The problem with open, and then if with open, okay. Questions and question list context that is forming in this only for question list. If context with open, okay. For QA in QoS, question list is this in context. Record if context. For line in F, record, okay. Everything should fall in this. Let me check. Okay, I have the data now, but it is the zeroth data. Got it. What is the 10th data? What is the 100th data? Okay. What is the length of the data set? Length is this. It has 18,000, close to 19,000 records, right? That's a huge data. Quite close to what we have been now. Basically, fine-tuning a model with this huge amount of data, it will take huge amount of memory, resources, and everything, right? Now, so I want my model to have all of this knowledge. So first and foremost thing, I will have to check in my data into vector database. Now, I will not be doing it literally, that is. So what I will do is, because I have already done, like I said, this process takes around 40 to 45 minutes. Well, what I will do for demonstration purpose, quad underscore data 2 is equal to squad underscore data, squad underscore data of, I'll just take some 10 records, right? All 18,000 records I have. In real, we will work with them, but just for the sake of code to check in into the data, to check in into our vector DB, let's use this. Now, what I'll do is I'll just use this, write code to insert squat data to context into FAISS data store. Let's see if at all it is able to do it. Okay, I'll not use this because a lot of things are not present here. I'll go with my own. Okay, so first and foremost thing, what I need is unique underscore context. So best practices, unique underscore context is equal to list of. So as I put my data into set, it will automatically find the unique ones, because these things are very important. If you do not do all of these things, very likely you will not get any accuracy. You should clean your data also. If your data is not very clean, this data is quite clean as of now here, right? Unique context. Okay, I hope that this works. Yes. And then basically I will have to use text splitter. So already if my data is too huge, right, then I will have to split it into smaller chunks. Ideal chunk is 500. 500 is kind of 512 is best for all kinds of, accuracy. This is like tried and tested kind of, that you can try with 500. I'll try with 1000 as of now. You can take any, but yes, smaller your context is, better the result is. But if the information is spread across multiple context, then you will have to keep the context size bigger. I mean, then smaller one will not work. Now documents. I'll just go with the documents, right? Documents is equal to document page context for context in unique context, correct? Next is text splitter. What is the problem? Input value, unique context, some problem. unique underscore context. Unique context of 0th. Oops, this should not be the case. Let's that item context q underscore dataset for item in squad 2 and item of mm, 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 mm. Item in squad underscore data context is context. Context is equal to item of text. Unique context not append. I mean, this is also one way. Either we can first add it into the list and then we can have the set and we'll have to convert it back into the list. I mean, the whole point is we want it to be unique. That's it. Right. We have it. And then documents, prepared the documents, correct. Text underscore splitter is equal to recursive character. Now this I read it from LangChain documentation. It's not that I remember all of that, right? Chunk underscore size. I'll keep it as 1000. Like I said, 500 is the best, but I'm keeping at 1000. And chunk underscore overlap is equal to 100. So 100 will be kind of, so if there is any continuation, many a times what happens that some information might get like left out due to splitting is happening. So in two chunks, in the end and in the starting, both of them will be present, right? Sorry for that. Just give. Yeah, sorry for that. Okay, so okay, we will have to, I guess, import this text splitter. Let me just from Hugging Face, sorry, from LangChain, chain text splitters. Import recursive text splitter. That's it. Easy. And let me import it. Why is it from LangChain cannot import? Sorry, it should be LangChain dot text splitter. LangChain dot text splitter. LangChain dot text. Cannot import name recursive text splitter. I guess we will have to pip install LangChain text splitters. Pip install LangChain text splitters. Although it is suggesting, let's see, accept and run. Okay, it says requirement is already there. And then again, it is telling me to change, and change worked. I do not know what was the problem. Okay, so we have this here. Text have been split, and now I have my embeddings model already in place, right? Embeddings I have already used, right? This model is already in place. Now, next is all I need to do is I can go ahead with vector underscore, but I did not initialize vector underscore store. Okay, vector underscore store, I guess vector underscore store is equal to FAISS dot from underscore document
You
and
can use any DB, right? Even Chroma DB should be fine, right?
for production try to use vwait.
We wait. Q. Okay. How about Qdrant?
Quadrant also you can use.
Okay.
Yeah, you will. I mean, I checked 2 months ago. You will have to go and check, which is having the best algorithms for searching. So, what is the score of searching? So, I was searching some 2 months ago. So, I was able to find out that VWeight had some better algorithms as compared to other.
Okay. Okay.
Okay, and now vector store is there. Okay, so this has happened in a very short amount of time, right? Because it was just 10 documents. Now, ideally, if it is 18,000 documents, this is going to take some at least 40 to 45 minutes on CPU. On GPU, it might be a bit faster, so it might take 15 to 20 minutes, but still, depending on where my embedding model is, this is what it will take. So what I have done, I did actually prepare that file, and I had loaded it. I mean, I had saved it, and I'll just pull that file. Okay, it is almost, I guess. Oh, is it not opening? Download essence files. Okay, so Mhm. Okay, and it's done. Now I can directly use this file for my, where is it? Where did it save? It has gone into, I guess, content. Yeah, here it is. All right. Now next is I have my LLM model loaded. Right. This is my LLM model, and I have my embedding model. Now I have, what I have to do is, first and foremost thing, let's load my, what is my, let's say, index underscore path, wherever my FAISS DB is present. So it is present here. I hope it should not create any problem. And then I'll try to load it. Loaded underscore vector underscore store. Vector underscore store is equal to FAISS load local. And embeddings. Nope. Oops, oops, oops. Malicious payload. Mm, 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 mm. Okay. Allow dangerous serialization because it is from external source. So this flag has to be added. And next is, once it is added, I'll also use retriever. Retriever is equal to loaded underscore vector underscore store as underscore retriever. So this is by default retriever that I'm obtaining. Okay, let me run it. Okay, this is done. Now next is basically I'll have to create my prompt. So this prompt will be basically for my LLM. Like, I'll just take the chat, or uh, prompt is equal to chat prompt template dot from underscore template. Chat prompt template we might have to install, I guess, right? From LangChain. Right, okay. All right. I'll just prepare the prompt that answer the user's question based on following context. We'll keep it simple. What is context? And context is this. And then we have the question. Question. Question is my, anything I can take input or question, whatever I wish to. It doesn't matter. We have to bind it, right? Okay. Chat the chat prompt is here, and now we can just prepare the document. I mean, we just need to query it, right? Document underscore chain is equal to create underscore stuff underscore document chain, I guess. Create rag chain. Accept it. Okay. Create stuff documents, LLM and prompt, retriever and question answer chain, document chain. This should be question answer chain, right? Correct. And done. Now, how do you test it basically? How are you going to test it, right? First and foremost thing, let's say I will just have any one sample question. Let's say I will go with retrieval underscore or rag underscore chain dot invoke rag underscore chain dot invoke any question as input, because I had taken input there, and you mark your question here. So I'll write my question different. Question, and let's say now I will have to use questions, that were present in my data. So I will pick up one small question, from director of Science Museum and Library. Who was the director of Science Museum and Library? So the answer is Father Joseph Career CSC. Let's see. Who was director of Science Museum Library? Question. Generated answer and response. I should collect my response here. And answer is equal to response of output. Response of answer, I guess. Now let's see. Okay, so it did not provide me with the answer, but provided context, it says does not provide me with the information. Now what can I do as of now? So obviously it is not able to fetch this thing right now. At least I can retrieval chain. I have to provide increase retrieval arguments up to 10. So here what I am doing again, so instead of relying, when one answer is required, it will pull up 10 candidates, whatever the k is, it will pull up those many number of candidates. Let's see if it is able to do all of that now. Again, so it is not able to actually pull this. Now let me try with something else. So what I have done, basically there is no point in going and checking one by one. So I have actually prepared one small JSON here, right? So I have a small JSON, and I will just upload that JSON. Hold on, or I'll just copy paste it. Test questions. So basically I have some 10 test questions, right? And this is the answer. What is the oldest structure at Notre Dame, old college, in what year college, and all of those things, right? Test questions. Okay, right. And now let me iterate run these test question over retriever and LLM and print the retrieved answer and LLM answer. Let's see, accept and run. Okay, let's see one by one what it says. Context is also there. Now print context, retrieved context, and then answer, LLM answer. At least I need few spaces here. Sorry. Slash and slash and. Let me run it again. And what is the correct answer? It is not printing the correct answer. Input question ground truth. Now ground truth is not being printed. What we'll do is we'll print here ground truth, right? Slash and the ground truth. Okay. Now let's see the results. Okay. The question is, what is the oldest structure of Notre Dame? And the oldest structure at Notre Dame is Old College. Ground truth is Old College, correct? Right? This one it did get it correct. Then the answer is a golden statue of Virgin Mary sits on top of main building at Notre Dame. A golden statue of Virgin Mary, correct? Next is the Virgin Mary allegedly, sorry, my system is hanging. I have no idea why it is hanging. So the Virgin Mary allegedly appeared at the to whom did Virgin Mary allegedly appear in 1858 in Lourdes, France? So it says Bernard Saint Bernard Soberius, which is correct, right? And then, okay, uh, it says, what prize did Frederick Buechner create? The provided context does not, this one it has failed, right? It was not able to provide the answer. The ground truth is Buechner Prize for Preaching. Next is, what entity provides help with the management of time new students? First year, let me expand it. Okay, this says it does not contain this one. The first year of student program provides, and this is wrong. The first year student provides help with the management of time of new students at Notre Dame, which is wrong. And the right answer is Learning Resource Center, right? So yeah, some answers it was able to get it correct, some answers it was able to get it wrong. But how do we get to know that how many answers are correct and how many answers are wrong? And then what do we do next to optimize it? This was a very plain and very like vanilla rag, which I tested its accuracy basically, and I have to show it to you also basically how to test it. So it was giving me around 78 to 79% accuracy. Now, in numbers, if you see around 80% of accuracy is good, no, it is not good. It is really bad. You know. So if any engineer or anyone simply sits at ChatGPT and just tries to build one RAG application, they will be able to build with 75% to 80% accuracy, which is a horrible accuracy. in terms of AI. Your accuracy should at least be around 93, 94%, or actually it should be 97 to 98%. Now, getting to that accuracy requires a lot of hard work, lot of things will have to do, which we will discover one by one. Now, I'll just discuss in first the theory. What are the next steps? Now, this is till where most of the people might reach, right? This is the step one, that okay, around what everyone can reach actually. Whenever you tell anyone to build a rack, anyone can reach this level. But then what's next after this? Now, let's find out what's next after this. This is where the role of engineer or basically a data scientist comes in. Next, like I said, it is the game of numbers. So what numbers you have to do is basically for optimization of the RAG, for RAG optimization, right? RAG optimization. There are n number of ways for optimization of RAG. N number of ways. N number of ways. First and foremost way is that, right? Use hybrid keyword search. Now, it is not simple keyword search like you say, it's simple keyword like, you know. So basically, we will see an algorithm called as BM25, which uses TF-IDF, advanced TF-IDF algorithm. Now, again, this is again not, I mean, TF-IDF is highly effective, but yes, it has its limitations, right? Use hybrid keyword search. First point, that is usage of better algorithm. Second point, use better embedding model. Use a better embedding model, right? We can go ahead and use a more powerful embedding model, right? Obviously, we can do that. Third point, right? Use metadata for with context. Use metadata with context. How does it happens? I'll teach. I mean, we will discover this tomorrow. How to use metadata with the context and how to extract metadata with the context. I mean, you can use a free usage models like Spacey, or you can use any model, NER, name entity recognition from Hugging Face, and you can just run it for free because on 18,000 of data set, there are some people what they have been doing, they have been running it on OpenAI even for detecting these metadata. Now, OpenAI is going to burn your pocket because it is going to be hell costly running this much amount of data against OpenAI. So yeah, I mean, all of these things are free. You can just get it for NER. You can just name entity recognition. You can download Spacey model, or you can download some best BERT Hugging Face model, which will do the job, right? Use metadata with the context. We'll do this. Fourth, use LLM to optimize query. So user may enter any query, right? User may enter any query. So what we'll do is we'll try to optimize this query, right? We will automatically try AI to optimize this query. Fifth point, obviously, is fine tune embedding model. Fine tune the embedding model. This is a small discussion that we'll do, and how do we fine tune the embedding model? We'll also have a look at it. So these are the ways using which you should be able to get a very good accuracy, with your rags. These are some of the ways. I am also basically planning to write one small paper how to improve the accuracy using, uh, I mean, some of the most more neural network based methods. You can, just via some easy steps, you should be it should be automatically able to increase the accuracy. But first I'll have to find out. I hope there is no such paper or that is already existing, because this idea has been in my brain since 1 year. So I do not know if someone has already published this method or not. I'll have to find out. So basically, yes. So these are some of the very common methods in, finding the best accuracy. And then we will also go further, which we'll won't be able to do it this week. We will go further and we'll go ahead and discuss graph rags. Very interesting topics, graph rags, right? So we'll be seeing this and when to use graph rags, when to use you know these, and how to combine even both of them. We'll see these. So since lot many people are absent today, I'll keep this session short and limited so that everyone can revise and come back tomorrow. So I'll keep it here. I'll share all the notebooks uh, right now in 10 minutes, right?
Then, before
Yeah,
we close, just one basic doubt.
yeah,
Like
yeah, yeah.
now